Alrighty, here we go. I don't want to sugarcoat it. I want to be honest. We're getting significantly tougher when it comes to the proofs now. Okay, it's not just a couple steps and I write side now. Right, it's going to get a little tougher. So I do worry about you guys that still struggle with the proofs. Hopefully, you're going to figure out that you do struggle and come on in for a little extra help. But that's your call. And some of you that are doing well, you might experience some issues for the first time. I gave out colored pencils. First proof we do right away. Notice the triangles I'm trying to prove congruent. They are overlapping, right? Overlapping. And anytime triangles overlap, I love to see them in two different colors so I can see what the sides are to each triangle and what the angles are to each triangle. All right, we got everything set up. Okay, first thing I want to do is look at each given and see if I can count it as a side or an angle. TR congruent to TS. Are those sides in the two triangles I'm trying to prove congruent? No. Again, this goes back to the quiz. You can't count those as sides. They're more than sides. They're bigger than the sides. So I can't put an S next to that. Next given, TM congruent to TN. Can I count those as a pair of sides in those triangles? No, we cannot. So really, what are we looking at? We're on the hook for all three pairs of corresponding parts now because I did not give you any sides or angles. All right, let's take a look. Is there anything I can see there that I can get a pair of sides or a pair of angles congruent? Is there anything I can see? Claire, you're going to start us off? I won't do numbers for this one. I'll wait till the next one. Claire?
TS minus TN equals TR minus TM.
So we're doing subtraction to get a side. Yep. How many pairs of equal quantities do I need to subtract? 2, and lucky for us, both of them are in the givens already. So I can go right to subtraction. TR minus TM equals TS minus TN. Subtraction. And everything's staying the same, right? Right after subtraction. Substitution. To say MR congruent to NS. And I got a pair of sides now. 1 down, 2 to go. 1 down, 2 to go. All right. What do you got back there?
RS is congruent to RS for the reflexive.
Yep. And that's why I like colored pencils as well. You can definitely tell those two colors overlapping each other. That gives me a side. Okay, let me discuss with you the same thing I did last period in my other honors class. How many methods do we have to prove triangles congruent?
5.
We got 5, right? I just narrowed it down to 2. What 2 did I just narrow it down to? Side, or it's going to be? Okay, it's got to be one of those 2. If I already have 2 pairs of sides, I know it's got to be the third pair of sides are going to be congruent, maybe, or the angles in between are going to be equal. It's got to be one or the other. Stop looking at the diagram elsewhere. It's either going to be the third pair of sides, MS and NR being congruent for whatever reason, or it's the third, or it's the second, the angles in between, which would be angle MRS and angle NSR. It's got to be one of those 2. And please remember all the work we did yesterday. Thanks, bud.
You're welcome.
Have a good day. What type of triangle is triangle TRS? Isosceles. What did we find out in an isosceles triangle? What is across from the 2 congruent sides? Are those angles in the triangles? Okay, you got your third pair. All right, what are those angles called now? Angle. You can go TRS or MRS. They're the same angles. congruent to angle NSR. And we wrote this down 3 times. I know as being a broken record because it was for this. How do I start this off?
In a triangle.
Got to be in a triangle. Congruent, and I don't care what you put next. We'll put angles are across from. In a triangle, congruent angles are across from congruent sides. There's the angle. So now we have to start looking for isosceles triangles too. All right, we need to start looking for isosceles. And then that should be enough. Step 6 should be it. Side angle, side. Anything, a little tougher now. It's all nice and easy when we do it together, but when I let you go on the assignment, it's going to be whew. Anything you want to ask differently? All right, what do you say? Next one up. 2 more overlapping triangles. Ready? Let's go through the givens. Can I count them as sides or angles? AE congruent to ED. Can I count those as a pair of sides? Yes, I can. That's full pair of sides in each of those triangles. I'm proving congruent. All right, let's go to the other pair now. Can I count AB congruent to CD as a pair of sides? Nope. Well, I'll use them, but I can't count them. All right, before I call in the first number here, this happens all the time, and it sounds funny when I say it, like who would ever do that? But we do. There's people who do it. When you use reflexive, that's only for angles and sides. Triangles cannot be reflexive. You cannot add or subtract triangles either. Okay? You can only add and subtract angles. So if you ever come in that desperation mode, please do not try to add or subtract triangles. Triangles cannot be reflexive. All right, so I need 2 more pair. Here we go. 2 more pair are up here somewhere of sides or angles. Where are they? All right, let's get this party started. 23, see anything? Yep. And we're not, Maddie's not counting that as a side. She's going to use it for something else coming up here. If you want to continue on Maddie's thought process, you can. If not, you can go somewhere else too. Nothing's got to be in a particular order here. 3, where else are we going?
AB plus BC.
Yep, let's just go in order here. AB plus BC equals CD plus BC. Addition. Bless you. And then I'll just take care of it, right? Substitution. To say side AC is congruent to side BD. There's a second pair of sides for us kids. So I think we've narrowed the 5 down to 2 again, right? Side, 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 angle, side. So it's either got to be the third pair of sides or the angle in between. It's got to be one of them. It's got to be true. Where are we going? 26. Where are we going?
Angle EAB is congruent to EDC.
Got it. These angles here, A and D, because what type of triangle is EAD? It's isosceles, so across from the congruent sides are congruent angles. And I can name it with one letter because there's only one angle there. In a triangle, congruent angles are across from congruent sides. And before we go on to the next proof, I just want to make a point here. Triangle AEC, congruent to triangle DEB, side angle side. I'm going to say an incorrect statement and mark it on my diagram, and I want you guys to tell me why I'm wrong. Using this theorem, in a triangle, congruent angles are across congruent sides. Here's what I'm going to say. Since AB and CD are congruent, so are the angles across. That's false. Why? AB and CD are not contained in the same triangle. Remember that. The congruent sides have to be contained in the same triangle. If they're in two different triangles, this theorem does not apply. All right? Same triangle only. Questions? We got two more together. All right, let's go. Hurry up. This is ridiculous. All right, you'll notice on this one, we got a little different proof statement, right? It's not in the givens anymore. Now we're proving the triangle is isosceles. So let's talk. There's really two different ways we could do this. What makes a triangle isosceles? It's okay. We could prove two of these sides are congruent. Or maybe we can't do that. Instead, we do what? Prove two angles instead. Or whatever comes first. Both does not have to happen. Whatever I hit first. All right, if I get 3 and 4, anybody see anything? I also wrote 1 and 2 in for you guys to pay attention to it. See it. Bridger? Are they supplementary? I don't see that anywhere in my statements. You might be thinking it, but I don't see it written down anywhere. You need to still tell me they are. We just used the word.
Exterior.
Okay, what? Ready? Back up. What theorem do you want to use right now? Eventually, what theorem do you want to use? Supplements of? Okay, the problem with that is you never said any angles were supplementary yet. So in step 2, I'm not ready to say that until I say angle 1 and are supplementary, yep. And angle 2 and are supplementary. Anybody got a reason for that? Same reason, John, we've been using all year? Yep. Good. Now, after you say they're supplementary, now you can tell me, hey, 1 and 2 are congruent. Because if you look, 1 is supplementary to 3 and 2 is supplementary to 4. So both 1 and 2 are supplementary to two angles that are, which means they're congruent to them. They're congruent to each other. Supplements of congruent angles are congruent. Now, I know some of you may want to say, oh, now the sides are. True. I don't need that much, though. What do I already have? 2 congruent angles. The discussion's over. This is isosceles now. All right, reason? How do we know it's isosceles? Right? Well, we talked yesterday. This isn't definition of isosceles. How do we know this is triangle is isosceles? In a triangle, yep. What do I have here? 2 congruent angles imply a isosceles triangle. If you had sides, you write the word sides instead of angles. Questions? Oh, you ready for this next one? Oh, boy. If I didn't lose people now. All right, let's do this. 1 congruent to 9. Can I count that as a pair of angles? Can I put an A next to it? Can I count it as a pair of angles? Yes, I can. Can I count AB and GF as a pair of sides? Maybe I'm overhyping this, right? You already have a pair of angles and sides. You only need one more pair. So let's talk about this given right now. In triangle CDE, it's isosceles. The base is CE. What did we talk about yesterday? The base is the side that's not equal. So what is this given telling you? CE is the non-congruent side. So the given's really saying CD and DE are congruent. I don't have to write that. That's what that given is telling me. Everyone see that? All right. CD and DE are the legs. The third side, the outcast side, is called the base. Ball's in your court now. I need one more pair. Right? I need one more pair in those two triangles. Anybody see anything that's congruent to start off? Start off. Go ahead, Ellie.
Angle 4 and 6.
4 is congruent to 6 in a triangle. Congruent angles are across from congruent sides. All right, I'm not going to put an A next to those, right? Because those aren't in the triangles, but we're getting there. We're getting there. Other true statements. Here we go. What else is true about the diagram? Let's roll with 9.
Angle 2 is congruent to angle 4.
Okay. 2 congruent to 4. Now, I know as well 6 and 7 are. I'm not going to put those in the same step, and you'll see why. Because I think if some of you put it in the same step, you're going to miss a reason coming up. These are why, Dylan?
Vertical angles congruent.
Yep, vertical angles congruent. Look at the last two steps we wrote. 4 and 6 are equal. 2 and 4 are equal. Got your own statement now? Which two angles are equal now based on 4 and 6 and 2 and 4? 2 and 6 are equal. What do we call that? That's substitution. And see, this is what I think would happen to a lot of you is if you put both vertical angles in the same step, you would not notice this is a 2 substitution proof. And you probably just write it once, but it's actually twice. So now what's the other pair of vertical angles? 6 and 7. And does everyone see the second substitution coming up here? Two and 6 are equal. 6 and 7 are equal. Therefore, and look at that. Look where 2 and 7 are. In the triangles I need congruent. So try to avoid writing vertical angles all in one step. And there's the A I needed. Now it's just a matter of somebody telling me what's the method, angle side angle or angle angle side. Look where the side is. When you got the method, let me know. Which one is it? 10?
Angle side.
Yep, that side's not in between. Right. Okay, I get it. There's no homework, but you guys need to practice right now. So flip your paper over, please. I'm keeping to my word. You're not doing this at home. So flip it over. You and your group are doing number 1, and I want to see it when it's done. All right, because some of you guys are going to be deep if you don't practice. Yep.
Do we have to say that?
No, that's part of this given right here. Okay, that's already given based on this statement.
Right. When a given says lines are perpendicular, you have to say it's right angles.
Because that usually what it means, yes. But for this, it's base CE. That means the other two are the legs and they're equal. Okay? So you and your group, let me know when you're done with the first proof. It tripped up a lot of kids last class.